Example 1, write the equations of the following graphs in vertex form. So let's take a look at A, the first graph. We want to be able to write it in vertex form. So remember, vertex form is y equals a, and then in brackets x minus h squared plus k. So what vertex form tells us is what the transformations are from the original y equals x squared graph. So A tells us whether it's a stretch or compression, H tells us if we're shifting left or right, and K tells us if we're shifting up or down, and they also tell us by how many units we are shifting. So in this question, we want to be able to write it as a quadratic equation, and we have a couple clues that were given in this graph. So vertex form tells us the vertex of the graph. So the h and the k value are the vertex. And in this particular graph, our vertex is 4, -1. So we can actually substitute 4, -1 into the equation. Our h is 4 and our k is -1. So y equals a x minus 4 squared plus k, but it's a negative value, so -1. Okay, so it almost looks like vertex form. The only thing is a is still a variable. Your equation should have all the other values substituted except for x and y, but I still have a as a variable. And just by looking at it, it's hard for me to tell whether there was a stretch or a compression. However, I do know another coordinate on the graph. That other coordinate, and you can really use any other coordinate that's on the parabola, but I have a specific coordinate that I've labeled, and I can use that coordinate to substitute my x and y in order to solve for a, because that would mean that a would be my only unknown. So my other coordinate that I'm going to use is 2, 3. Okay, so I'm going to substitute x and y for 2 and 3. So y is 3, a I still don't know, x I'm going to replace with 2, and the other values I already know. Now I can solve for a. So I'm going to use BEDMAS. I'm going to do what's inside the brackets first. And I have 2 minus 4. Everything else stays the same. 2 minus 4 is -2 squared minus 1. BEDMAS says after brackets comes exponents. -2 to the power of 2, that means -2 times -2, which is +4. And I'm going to write it like this. Usually the coefficient goes first and then the variable. -1. I'm continuing to solve the equation. To get the a by itself, I need to get rid of this -1. So I'm going to do +1 on both sides. Opposite operation. These will cancel out, and I'm left with 4 on the other side is equal to 4a. To solve for a, I'm going to divide both sides by 4, and I get that a is equal to 1. So it turns out there was no stretch or compression. A is just 1. So therefore, the equation is y equals, so the x and y are going to be variables now, but I'm going to replace a, h, and k. So a was 1, so I'm just not going to put anything. X minus 4 squared minus 1. So that is my equation. For B, I'm doing the same thing. So I want to write my equation in the form y equals a x minus h squared plus k. In this case, I can locate my vertex. and it is at 2, 4. So this is my h and this is my k. That's what I'm going to replace. Y equals a x minus 2 squared plus 4. Again, I need to find another coordinate. This time I'm going to use the x-intercept. So really it can be any coordinate. It's nice to pick a whole number. So I'm looking for places where it crosses the grid nicely. And my other coordinate is 4, 0. So that's what I'm going to replace x and y with. So instead of y, I'm going to put 0. A instead of x, I'm going to put 4. Okay, again, brackets go first. 4 minus 2 is 2 squared plus 4. I'm going to do exponents. So 0 is equal to 4a plus 4. Still isolating a. I need to get rid of this plus 4, so I'm going to say minus 4 to both sides. And I'm left with negative 4 is equal to 4a. I'm going to divide both sides by 4, and I get that a is equal to negative 1 this time. So the equation is y equals negative x minus 4. Oh, x minus 2, sorry, I was looking above. X minus 2 plus 4. And if your a ends up being a fraction, you can convert it to a decimal if rounding isn't required. If you need to round, then just keep it as a fraction in lowest terms.